Okay, Goran, there is no more people waiting in the room, so I suggest we can start.
Yeah, thank you, Aleksandar. I will just be very brief with a very short introduction, and please take a look. And if we have more people, we'll let them join in, of course. Um, as everyone on this call, I presume knows, the data science Macedonia community, we've been organizing a lot of events before the pandemic, and starting. And in the past year, we did only one, if I remember correctly. Now we're about to change that in a positive way. We want to step up and use the opportunity that we have to create more online events and to share more knowledge. Starting today, we have another event scheduled, still not announced, but prepared for in a couple of weeks. I want just to share with everyone that we will share a message with everyone in the society on the Meetup group and on Facebook who wants to share knowledge, to sync with us, to connect with us, and we will try to organize at least one meetup per month. I think that's the best contribution we can make to the local community. And on top of that, we will not only focus on classical presentations of work done, but we will also try to bring in more people for fruitful discussion. And I see today more or less podcast type of meetup as a very nice step in the right direction. Today, Aleksandar will lead a very interesting discussion, but I will not take any more of the time. I will just wish you guys a successful meetup and looking forward to the questions at the end. Bye bye
Thank you,
for now.
Goran. Thank you for your time. I will go on with the podcast. So, hello and welcome everybody to this episode of Energy Industry and Time series. As Goran mentioned, my name is Aleksandar from Scalefocus, and I will be the host of this podcast. So today we are going to talk about energy industry in general and digitalization of the energy companies, but also how technology helping us with better planning, creating some strategies and on-time decision in this very dynamic world. But before we start, as Goran mentioned, for all interested in this topic, please write your questions in chat. And on the end, we will have a Q&A session and try to answer all your questions that will be inside with a very brief and explainable answer. But please, before that, don't forget to specify to whom your question is going to be. So please appoint someone from the speaker. As you see with me today, I have two guests. One of them is my colleague, Kiril Zhelev. Currently, he is head of energy utilities and consulting at Scalefocus. And his fields of interest actually include project management, business development, energy trading, risk management, and digital transformation in energy companies. And most of these topics actually will be touched today. And if you have some interest inside, please write your question as we said in the chat. On the other side, I have Hristijan Gjoreski. Currently, he is assistant professor and researcher at Kiril and Methodius University on Faculty of Electrical Engineering and Information Technology, popular FATE. He is also co-founder of Idea Labs, and his fields of interest cover artificial intelligence, machine learning, ambient intelligence, wearable computing, activity recognition, time series, and many more fields in computer science. Hristijan, please cover something if I forget, but I think I cover most of them. So unfortunately, the third speaker, Gjurchinoski, will not be here today for valid reasons. So welcome, Kiril, welcome, Hristijan. Now thank you all for being here, and thank you also for being here this evening to share your thoughts on the energy industry and time series. And as a brief introduction to this podcast, I think we all agreed that the pace of digitalization of the energy companies increased during the years, and more energy suppliers are trying to establish some connection and direct relationship with end customers. and switch on companies to find smarter way to manage their resources. So according to this statement, Kiril, what do you think? What are the major challenges in the energy industry? How are Varya's companies affected?
Hi, Alec. Thank you, first of all, for the invitation and for the brief introduction. So, from my experience, I'll just try to share a bit more of like holistic view of what are the major challenges in the energy industry, because this topic per se is quite vast, and we can talk about it like spending at least an hour only talking about this topic. But I'll just try to cluster a bit some of the topics and the challenges here. So first one, let's just say that like the market is much more integrated right now, and which means much more competitive. So this definitely changed the model and the way that energy companies have produced, like generated, used energy, how they are trading and how they are integrating in all interactions with all market participants. So this is definitely giving a lot of push in terms of competition and being more integrated and tightly coupled in terms of especially energy markets and energy trading. From other hand, we have definitely the geopolitical factors. I mean, for sure, energy markets have been always tightly coupled with geopolitics, and generally speaking, there are a lot of influences there. We, just to give an example, for instance, last year when there was already, I mean, the first months after the COVID, of course, the demand, for instance, for instance, oil demand changed drastically. We also have seen, for instance, the several interventions from OPEC in that regard, and we have seen several corrections in the oil prices. Now we see that there is certain rebounds, but of course, this has been a major topic for several times. Other major challenges, I mean, or influences, I mean, environmental, we are more and more conscious about the impact that we have on the, I would say, on the planet. I mean, decarbonization is a topic that has been on the table for several years, decades. But I mean, companies are more and more investing in that direction, and we see a lot of emerging technologies and emerging trends in that direction. So this is also a very interesting topic. I mean, purely from operational perspective, energy companies are trying to be more lean, be more competitive on the market, and we have seen a lot of investment from their ends in direction of being more operationally lean, reducing their costs, trying to standardize their operations, and in a more pragmatic way, this is very often translated in further investment or rethinking of their IT landscape and digital footprint as companies. And of course, one of the last challenges or major topic that I see as having a major impact is kind of the regulatory framework. Since, I mean, like a post-financial crisis actions, we have seen several regulations which primarily have been created in order to regulate and to provide more transparency on the financial markets. But these have been translated in the energy trading, since there is a lot of commodity and also derivatives trading, which are impacted. So in a way, energy companies have been obliged to invest also in terms of investment in regulation and also some frameworks in order to be compliant with the new regulations. So I guess this sums up some of the factors that are heavily influencing and having a major footprint in terms of the energy challenges.
Yeah, yeah. Kiril, you mentioned several challenges like market challenges, geopolitical, operation, regulatory challenges. So how energy companies or industry players are responding to these challenges? What is your opinion?
So, I mean, as I kind of mentioned something in that direction, I mean, the most frequent response to this is trying to be more lean as organization, no matter if you're in the upstream, midstream, or downstream. So, from my perspective, cost optimization and cost efficiency measures and topics have been heavily explored by companies. In that regard, I mean, there is a major investment in terms of digitalization and IT transformation in order to cope with the constant changes that we see. I mean, energy markets are very dynamic, extremely dynamic, and companies needs to cope with these changes. So the best way is to have an infrastructure which is actually able to cope with these frequent changes.
Yeah.
And yeah, I mean, this is pretty much the whole topic that I would say is the most persistent in that direction.
Mm-hmm. Generally speaking, energy companies with their digitalization have needs of support. I know that they're experts in their fields, but when there is coming digitalization, they need some support and some experting. And you are coming from Scalefocus, which is a service-based company. And as a company, how Scalefocus can help energy companies facing similar challenges?
Yeah, so as you mentioned, energy companies, their core business is actually around energy. So we see kind of a transition right now, energy companies becoming more and more also kind of IT companies in that regard, because they are, I would say, a natural force in that direction to become more and more having a more technological background in that regard. So yes, we as a company, Scalefocus is a technology and services company. We are working with energy companies in several directions, and one of the major stream that we have with energy companies is related around, I mean, digital transformation and IT landscape transformation. As we previously mentioned, one of the major challenges is that energy companies, I mean, every company has its own digital roadmap currently. So of course, some are more advanced. Other companies are kind of in a earlier stage of development in their digital roadmap. But we as a company actually support these companies in fulfilling various steps in their digital roadmap. It could be, from one hand, it could be in their data initiatives, or it could be from their trading perspectives. We're working with a lot of energy trading companies, trying to kind of improve in several areas. It could be the digital management and the data journey that they are having, because one of the major pain points that companies are trying to mitigate is having, I mean, the data, having clean data, removing data silos and kind of redundancy. In that sense, having a lean data infrastructure. So we are actively working in that direction. We have also a lot of kind of initiatives and projects which are more related in cloudification, enabling transition and change using emerging technologies, using AI, machine learning, implementing various models, working with them and supporting them in order to enable running these models, training them, and using them in a real situation. So I would say there are quite a lot of different streams in that area.
Yeah, when we're talking about some modeling, trading, and so on, you mentioned energy trading and how Scalefocus helps companies actually in optimizing and automation of business processes. What is the added value of forecasting in energy trading industry? Can you explain us a little bit about that topic?
So forecasting is, I would say, kind of a backbone for having successful operations on the market. So from one hand, I mean, the energy markets, it's also a lot of related to having a balance on from one hand from the generation and also from the consumption. So I mean, especially on the energy, I mean, the power markets, I mean, forecasting is becoming extremely crucial in order, especially in the short-term markets. I mean, having a proper forecasting is substantial, and I would say most of the energy players are heavily investing in that regard and trying to get better and evolve in that regard. We also need to consider the latest trends in that regard. I mean, we see renewable energies becoming having a more substantial part of the overall energy generation mix. And in certain cases, I mean, we see that the consumers of energy may become producers if they own their own, you know, solar panels or even small devices. They may put this energy on the grid. So definitely, the importance of the so-called prosumers will definitely grow will become more intense in the future, and definitely this is heavily impacting the classical model of kind of forecasting, where usually the generators are, I mean, exclusively generation is being forecasted by following the generation part of the market, and with the prosumers, definitely this is kind of a disruption that becomes more and more reality.
And what are the trends and innovations?
Can I ask one question there? So while I will use this opportunity, the privilege of asking questions compared to the audience. So Kiril, you mentioned that you're also working with your energy clients, let's say on machine learning, data science. Can you share more about this? How much this is important for the clients? Because we all know people are skeptical about machine learning. Nowadays it's becoming more trendy, let's say, but is it changing the landscape in the energy industry?
So it's difficult to give a single answer here, because as I mentioned, we are working with different companies, and they are in their own digitalization path. So definitely we have some examples where companies are already kind of heavily relying on models, using and more pushing in direction of automating even kind of algo trading, and even automating their kind of the even final decisions in that regard. However, of course, there are certain companies that are kind of right now in I would say in an early adoption of technologies, like having big data, having more cleaning data, and out of it afterwards the next step would be actually to go in further that regard. So it's very difficult to give like a conclusive answer here. I mean, definitely there are certain companies that are I mean, having I would say a bigger market, and maybe going more in direction of digitalizing further in that direction.
Yeah, and regarding that one, actually, it was my question that I want to further continue with that, what are the trends, Kiril, and the innovation today that, for example, energy companies focusing today? What they mostly use?
Well, I would say the first prerequisite for adopting the latest technologies. When I'm talking about latest technologies, I'm talking more about IoT, machine learning, using this data and providing a meaningful analytics. So, I mean, the prerequisite for all this to happen is, of course, having a clean data and having enabling kind of big data capabilities, which I would say 5 years ago has been kind of like a buzzword. Now we definitely see it's implemented in kind of in productive environments. And kind of latest trends, I mean, we see more and more IoT metering services are becoming again in their being more used in a productive environment. So there is definitely a great potential there. We see a lot of use cases that are emerging also related to IoT, which are related to more asset management, you know, management of power plants and using it for preventive maintenance. I mean, there are a lot of use cases there. So, I mean, it's very interesting. But of course, as I mentioned, the prerequisite for having all these is definitely having good, clean data and having kind of big data usage.
Yeah, this is nice to hear, because all this data that we are working all the time, we're trying to clean it and try to find it, and 70% of the work actually is doing some cleaning and after it some modeling. So I will transfer the mic now to Hristijan, because I know he's also have some experience in energy industry. And Hristijan, we have digital transformation and innovation in general terms, but what technical challenges are energy companies facing?
Ooh, what kind? All kinds of technical challenges, I would say. I mean, all the companies which are not primarily computer science or software-based companies are having this transitional period towards digitalization, which is not that easy to do. And the energy sector, as much as I know it, it's also one of the slow ones, slowly moving, adapting new technologies. And that's why I asked Kiril about how much data science or artificial intelligence is incorporated in this energy sector. So I would say it is changing fast. So the energy companies that are kind of maybe even startups or smaller, more dynamic ones are probably adopting these new technologies, new sensors for measuring different kind of parameters of the energy sector, how much you're producing of the energy from the renewables every minute, every second, if you wish, or every 10 minutes. So also this resolution of data acquisition is going down. So in the past we had like, how much energy did you spend in one day or in 1 month or in 1 hour? But now this resolution is going down and down and becoming to this close to near real time, let's say, decision-making processes and similar. So all this is actually going towards this Internet of Things, all these devices measuring something, producing data, streams of data, going back to big data, cloud technologies, how to process this data in real time, how to make decisions in real time. So all this is actually happening right now in a lot of industries, but especially in the energy sector and the energy industry. So maybe, yeah, I'm biased actually here. I'm talking more about data science, data sensors, but actually the biggest problem with the energy industry in general is that we do not know as a society, as people, how to store energy. If we solve that problem, then this shouldn't be a problem and we won't have probably this kind of talks. So if we know how to store energy, better solution than the current batteries, most of the problems will be solved because we are producing a lot of energy. Now the question is, I need the energy now. Can I produce it now? Not always.
Yeah, and when we are coming to this part of talking about technologies, measuring this technology, some prediction, machine learning models, all the time when we have time and especially energy, we are coming to time series. So why we use time series? Can we explain this buzzword? It's not a buzzword actually, but time series is something overall, you know. And if we are specified for energy industry, how we can explain it?
Well, why do we use time series? Because the data comes in that kind of format. Because we have time, and then you sample, I don't know, you record some data point, and you end up with the data set that was recorded in this time period. Time series is a pretty strong buzzword in data science, but in general, and how to deal with time series. So there is no like. Even in machine learning, you do not have an algorithm that, I don't know, will calculate everything or will solve time series problem.
And if we had that kind of,
if we had a general algorithm for time series, we will just use it and it will solve all the answers. Each time series, it's a different story. Each time series has different context. So the context is really important. So if you're training, I don't know, stocks, Google stock, will it go up or down? It depends on the context. It's not just the trend of the stocks, but also it depends, I don't know, if some major release has happened, or also the speculations about stocks and everything. And the same thing happens here in the energy sector. So it's not like if you have a time series of the power consumption, how much I'm consuming electricity, for example, right now or in the last day, you have a time series, time point, which will tell you at 1 hour it was this much, at 2 hours it was this much, and so on. So it's not just the point itself. It depends what was it a weekend, for example? Am I home? Am I at work? What is the weather outside? If it's too cold, probably I'll turn on the heating. If it's too cold, if it's too hot, I'll turn on the air condition. So all this contextual information is really important to analyze this time series, which I'll have probably opportunity to talk more.
Yeah. I have a special question for you because I know you have one research about that one. But let's say in general, we are using time series for representation and measurement. And can you explain time series analysis in energy industry, specifically I'm saying for household power consumption forecasting, because I know you have some research in this field.
Yeah. So that is probably my biggest reference so that I can be part of this panel or podcast. So my background is in machine learning, data science, analyzing data, sensor data, and that kind of, let's say, things. But I'm also teaching at the Faculty of Electrical Engineering. So we have a lot of electrical engineering, let's say, projects going on and similar. So it was just a matter of time when I will also do something, data science in electrical engineering department, let's say. So what we did with this research is actually we created a machine learning model that is able to predict 1 day in advance how much the household will spend energy. So for example, the model early in the morning today will give predictions for the next day for every hour. So it will say, I don't know, from midnight to 1 hour, you will spend that much energy. Then from the resolution that we used in that research was particularly 1 hour. So this study was actually together with the Faculty of Electrical Engineering on one side and Iskrotel ITS company, which is here in Macedonia. So actually, they were the one saying to us, okay, we have this problem, can you solve it? Can you create a machine learning or whatever statistical model that will predict the consumption of the users of the household the next day? And there we said, okay, first let's find a data set. That is the most important part when you're doing data science and machine learning. It was really difficult to, yeah. So first we thought that the company Iskrotel has some data sets, but they were not appropriate for solving this kind of problem. And at the end, we were lucky enough to find a publicly available huge data set about this kind of problem. And this data set was about USA for Texas, Austin, Texas. Most of the households were in Austin, Texas. There were approximately 1,000 households, and the data set was collected for 4 years. So it is really huge data set which is a dream for every machine learning or data scientist. It was clean enough, so we didn't spend too much time on cleaning and everything. Here I must say that most of the work on this work was done by Simon Stankovsky and Ivana Keprianovska, with whom I'm still collaborating on other projects. If they are here, a really good job. So this podcast actually made me go back to this research that we did, and I saw how much energy we spent in this actually. Not energy, electrical energy, but time and effort to do this research. So basically, what we did there, so the machine learning part a little bit, was not to take only the historical energy expenditure of the household and to say, okay, because in the last 10 hours you are spending this much, this is what you will spend in the next hour or the next day. We also use this contextual information, the context. So the calendar days, which month, which day of the week, is it a holiday, is it a weekend? And also we added the weather information. So the weather information is actually really important, how much I will turn on my air conditioner or the heating. And by combining these features, contextual features and the historical load features, we were able to create a really good feature set, which was then fed to a deep learning model or any machine learning model, which was able at the end to, I don't know, to be better compared to all the benchmark models that we tried in this particular research.
And according to this paper that you done previously, can you explain your research result? What was the result at the end? Okay, we know you didn't struggle to collect the data. This is maybe the happiest thing to this project. After that, you did a lot of work, but what was the result of this research?
Yeah, so what were the results? First of all, in order to publish something scientifically, you have to, I don't know, have something new. So there are several new scientific components. So combining this new feature set, also using deep residual blocks, so some deep learning models was novel in this sector. And we showed actually in this paper that we are better compared to state of the art in a way. Why I'm saying in a way? Because you cannot directly compare to others if you're not using the same data set. And that is usually difficult to compare directly to others. But we did our best to compare it with other research studies and similar. So first we showed that we are slightly better. The error that we received was significantly lower compared to the others. If I have to put it in words so that we can all understand. So for example, we did hourly analysis and daily analysis. So the hourly analysis showed us that if we make an average on of the hourly consumption by all the households, is around, for example, 260 kilowatts per hour. And our model made 8% error in the prediction of these 260 kilowatts per hour. And nice. For example, the best baseline model to which we compared made 20% percentage error. So this 4 percentage points, even though they don't sound a lot, but when you convert them in kilowatts per hour, it is a huge, let's say, improvement. And for the daily consumption, so if we make an average calculation of the error for the whole day, our model was around 2% of error, which was much better compared to the benchmark model, which achieved 6% of error. But again, if you just see look at the percentages, they don't show the whole
great.
picture. Yeah, but still, I'll encourage you to the ones that are interested, please contact me. I can share you the paper. And also, what we did actually here is it was not just okay, let's do some research, publish in a journal, but we also tried to deploy the model. So we also went those steps in deploying the model and see how it will work, let's say, in a quasi real-time environment. Because I'm saying quasi because we never tested it in real life. We just deployed and simulated, let's say, an environment for real-time execution of the model. And that was also really, really nice to see the model, how it will behave, or how to do visualizations to give feedback to the user, and similar.
Great. We have already born baby, so we will check on it maybe in a few years if this model actually get in life directly. So I want to continue with something else because we are getting sense that we are using modeling in forecasting, but what kind of model we are using in time series? For example, all the time I'm asking myself how traditional statistical models directly compete to AI and machine learning based algorithms in time series. These days we have a lot of powerful models in machine learning and AI.
Yeah, so this is quite often asked questions. Asked question, I would say. So actually, we at the beginning we didn't try these traditional statistical approaches like ARIMA or SARIMA and similar, but one of the we directly went to machine learning and deep learning. But one of the reviewers, which was reviewing the papers, suggested, okay, can you compare with these traditional ones and see what is the comparison there? So we did the comparison. First, what we noticed is that the SARIMA, for example, model, which takes the seasonality, which is important in our data set, into account, was training, let's say, much slower compared to the deep learning, which was a shock for us. But the reason for this I'm not expert in this SARIMA, ARIMA models. Maybe there are some things that can be tweaked, but the reason that we speculate is for that is that those models were invented when the data sets were, I don't know, hundreds of samples, thousands of samples. And in our case, we had like millions of data samples, which is quite a lot. And waiting for the SARIMA model to fix the coefficients was really, I don't know, waiting for 2 days of fixing coefficients, which was much worse compared to even advanced deep learning approach. At the end of the day, the results with SARIMA were not good at all. And the reason for that is that it is not taking into account these contextual features that I'm mentioning all the time. So actually, we compare it also to LSTMs, gated recurrent units, which are, let's say, the way to go if you have sequential data, but not often they work well with time series, which is contradictional, but it is the case right now in data science. So our feature extraction was crucial for our model to achieve those kind of results. Extreme gradient boosting with our features was also really good. So I would say these standard machine learning techniques are also good if you have the right combination of feature engineering.
Yeah. I understand, because feature engineering probably is state of art in my point of view. If you have great feature engineering and data preprocessing, then you did already everything. Afterwards, you have to only put some models, not some, but you have to choose from them. But exactly, if you're doing great feature engineering, then you're on the right path. One more time, just to mention to everybody, because I don't receive any question and comments, please do not hesitate, write your question in chat. So at the end, we have a brief explanation about them. Please write it in chat. Let's continue with, I have a few more questions. We won't get a long time with this one. On one hand, we have power consumption, Hristijan, but what about power generation? Can we optimize power generation based on this knowledge of household consumption?
Yeah, so the power generation is, as Kiril said, the other side of the coin. So we have the consumers, and we need to produce this electricity somewhere and somehow. Can we optimize? Yeah, I mean, we are trying to optimize everything in our life, right? So from the moment we get up, we are optimizing. So it is also normal to invent this algorithm that will optimize the power generations. But why do we need to optimize? Because we cannot store it.
Yeah.
We can produce a lot of solar electricity, let's say energy, during the warm, sunny day. But if we do not need it during the day, if we need the energy during the night, it's for vain. What will we do with that energy? Nothing. So that's why we have to optimize, and that's why you have also forecasting in the power generation area. So, for example, if I have a model that will tell me how much solar energy my plant will produce tomorrow, I can better plan this. I don't know when to sell on the market the energy, when to, I don't know. So the solar energy is just one example. Another example is the hydro plants. So I had a master student. Now she's becoming a Ph.D. student, which she did her master's in predicting the water accumulation for hydro plants. So 1 day in advance or 2 days in advance, according to the weather conditions, to be able to know how much new water will come to the basin, or how is it called, to the accumulation. And this way you know how much new energy you will have tomorrow in the hydro plant and similar. So of course, there is also a lot of forecasting and optimization in the power generation side.
Yeah, so basically you explained these two endpoints, and I will switch something to Kiril, because recently there was a major event in Texas, USA, Kiril, that caused power disruption actually in distribution network. Can you, in distribution grid, can you comment on it? What are the major outtakes from this event? What happens there?
Well, first of all, it's very interesting that Hristijan did his study actually in for the Texas region. So actually, that's a very good example, and this topic is actually quite interesting here. So I mean, most of you have heard about what happened in Texas in February. I mean, some combination of events, really, how to say, the kind of force majeure events, or like the perfect storm. Let's just put it that way. I was just looking for the correct word. Perfect storm is probably the best expression here. I mean, it's very interesting, and it gives a lot of food for rethinking, probably redesigning certain aspects of how markets are integrated. We know that the Texas region is kind of isolated, and I mean, there are a lot of factors. I don't want to comment exactly on the situation there, because I'm definitely not probably the right person to really dig into this topic, but it's really giving a lot of thoughts, raising a lot of questions. First of all, in terms of integration, how what are the benefits of kind of integration with other markets, like some markets where, for instance, UK, it's an island, it's kind of isolated. Texas is kind of having the same model. isolated market. So from other hand, really think of how what is actually kind of a stress test? What could be the conditions, or maybe explore some extreme conditions and give more space for analyzing and testing different stress tests, like what if scenarios, which will definitely might, I mean, we don't know if there were some findings on this on these topics. I mean, what I read was actually there was a similar situation quite a few years in the past about this region, kind of a similar situation. Of course, they are not used to have extreme extreme cold in that region, and this was also like the I would say the root cause for having all the troubles afterwards. But I mean, it provides a lot of thinking of maybe where we might have a potential outages like this in other regions in the world, and eventually thinking how to from one hand how to predict those, how we can potentially better forecast in the future, and yeah, just to kind of try to prepare as much as possible. So this is one of the major things I have in mind.
Nice to hear. But before to go to Q&A session, I have one more thing, Christian, for you. If we take the outtakes that Kiril mentioned, can such events be solved or better predicted using technology? What is your opinion?
Well, I hope so. I would like to believe that we can potentially predict this kind of scenarios while developing the models. So this is not just a machine learning problem. I think the whole software development and everything. So when you develop some software, you have a phase where there is a QA. You're testing the software and everything. So if we add these extreme scenarios in this testing phase, like, I don't know, what if the temperature goes below 20 degrees in Texas, which never happened before? What if it goes below 10 for several days continuously? So this kind of stress tests that Kiril also mentioned are really important also for machine learning. Even though right now we are just saying, I have the data set, I have 95% accuracy, I'm the best, that's it. But actually you have to think a lot about how this model will live in practice. What are the potential attacks, if you wish, to this model that can trick the model, I don't know, to predict very high value or very low value or whatever. And these are things that, will probably happen with time. Once we adopt machine learning more and more, we'll see, yeah, this model works 90%, or for example, the Texas scenario, the system works 99.9% of the time. So it's nearly perfect. It's not machine learning model, but the whole system. But that 0.0 something, it's a huge problem because left few days without power, 4 million people. So that's two Macedonia. So you can imagine that.
Yeah.
So maybe we can borrow something from the airplane industry to have really reliable system, not just to work 99% of the time, but several nines after the point. To have a backup, of the backup and similar.
Yeah, so still robots will not take over the world, right? In recent years. Okay, thank you guys. I have now, I think that we should switch now to some questions that I already received, and I'm very glad that we have some questions. So thank you to all for this insightful discussion, and we can switch our attendance to our chat that we have in question and comments. I will read now the questions. This question is for both of you. So how does a company decide which model on paper might be beneficial for the company by implementing into the operational field? Put simply, how do I know as a company if your model on paper will work for my business? So take the mic, whoever wants.
Yeah.
This is for both of you.
Okay, I can try and be first.
Yeah, okay.
So yeah, that's a really good question, and it's happening quite often.
And actually, I think you already touched a little bit with explanation with this Texas case that this 0.01 actually can prove that this model maybe not work in the end.
So this usually happens in practice. So when I speak to potential client, let's say, and I say, I have perfect model, it will reduce the error or whatever, or increase the accuracy for 10% of your current system. How the other side can be sure that what I'm talking on this side is so first of all, it really depends if the model has been evaluated thoroughly. So it's not just to create the perfect model. You can always overfit and create the perfect model. So maybe the best way to do it is to say, okay, let's implement my model in your company and let it run for 1 month, if it's possible. That's the best thing. Let it run for 1 month, 2 months, and compare your current algorithm or whatever the decision you're making in your company and the decisions that the machine learning model is giving. This is the perfect scenario. Not always can happen in practice because the decision can influence the next day and similar. But it's a problematic question, and there is no one easy answer. It depends on the domain, it depends on the company, it depends on what kind of process you're substituting or trying to solve with the machine learning. The best way is to put as a prototype the model into practice and see how it behaves. And then once you're sure that it works, start from there.
Okay, then we can proceed if Kiril wants to.
I can simply add a couple of sentences here, at least from what I have seen from few energy companies and how they are tackling such kind of topic. I mean, I don't think there are many ways of doing this. And we have already mentioned probably the most proper one is simply analyze the results of the model. So companies are simply trying to put some playground environments where they can actually analyze the outcome of the models over a certain period of time. Of course, this is extremely important in that case. They can compare results. They can further analyze. And I mean, there are a lot of people with a special background here that definitely are spending a lot of time in examining such kind of model. So, I mean, I guess this is the universal approach in doing here.
Great to hear. I have next question for Hristijan. Hristijan, the goal of energy producer is to maximize its profits. How optimization of production contributes to this? And I have one comment after it. If trading the energy is viable, the company would sell the excess of the produced energy rather than responding to the domestic demand and produce less.
Can you repeat the comment?
The comment, if trading the energy is viable, the company would sell the excess of the produced energy rather than responding to the domestic demand and produce less. This probably
it's capitalism, right? The more money you make, that's why we have these regulatory bodies that are somehow supervising the whole thing. But I agree that's a problem, and it shouldn't happen. That I don't know, domestic-based companies selling electricity, let's say, outside the country, while we do not have energy here in Macedonia. So if I'm sensing that is the question, but it's a cruel world. So that's why we have this laws here and there to I don't know, forbid this kind of not responsible behavior.
Okay, I have other question. This probably is more for Kiril, not for Kiril, sorry, for Hristijan. What platforms and libraries you are using for building and evaluating the models, especially for the models already deployed as POCs or some production state environments?
So for the development, it's completely Python. So Python is the way to go these days with data science. Scikit-learn is the best machine learning library out there for the standard machine learning, let's say techniques, ensembles, decision trees, support vector machine, whatever. And then for the deep learning, we were in this particular research we were using Keras, which is abstraction layer on top of TensorFlow, which is library provided by Google. PyTorch is also really nice for prototyping. I've never used it, but I know people that are quite involved in the PyTorch. And about the deployment, I do not have a lot of experience there. Right now, I'm working in a project where we are deploying machine learning models. So it will depend on the environment where you are deploying the model. Usually, what you see is the model is expecting like calls on some server on cloud. So through API, you give the model some data, it gives you the prediction. That is the standard way of doing it. But of course, it depends. Sometimes it should run locally on the device, on the smartphone.
Yeah, I have one comment here from the same guy who asked the question. Great event, guys. Thank you for sharing your experience and insight. Keep up with your great work. Also, this is my first participation in Data Science Macedonia events, and I am glad that everything is organized on such a professional way. Thank you, Miodrag. We'll keep up with this event. I have other question. It is not always possible to sell the energy. It depends if the other side actually needs it at the moment. Actually, this is more comment. Probably we will agree with this one. There is ask for Goran to unmute him for some discussion. I will try now. Just a sec. Sorry for waiting, but it will be fast. Goran, you can go on.
Yeah, thanks, Aleksandar. I just want not to drop the question and the comment from the participant before, because I think I can add some value to that point. So the energy market, although we perceive it as a free market, is in fact regulated market, and there are quite not that complicated but strict regulations that govern it. The energy usually is scheduled a day ahead or 2 days ahead. And then you have to deliver on your promise as a company that generates energy. So if you vouch that you will generate certain amount, you have to deliver that. Any excess, you can sell it on the free market if there is a buyer on the other side. So that's a risky move. And in certain time slots and situations, you can gain a lot of value, but you can also lose because there is also negative, there are also penalties if you push more energy into the system than what you have scheduled for. So it's really complex optimization problem and maybe deserves a separate meetup. But please connect me with the person asking those questions. We can continue the discussion.
Yeah, we will write these questions to Goran also to check it, and we will find your name to answer something else afterwards. I have two more questions. How should we handle such edge cases that we explained already for Texas case scenario, which might cause problems in the real world when we don't have data to work with and train the model on? This is to Hristijan, but also I think that Kiril can said something about this case, because if we don't have data to train something, probably energy companies are prepared for some stressed scenarios.
Okay, so just minor comment from my side. I mean, I can also comment on the previous question. but let me just focus first on this one. So, of course, I mean, if there is lack of data, I mean, there is no much that we can do. So, absolutely, I mean, this is a prerequisite. This is a must-have, and of course, every market participant, I would say, it's not only from the generation or consumption side. Everyone should kind of be ready and kind of enable such kind of data provisioning in order to make it work in a sense. So this is kind of a prerequisite, and I can't really think of an easy solution on this one. I mean, energy, especially the power market, is extremely interesting. I mean, the lack of like substantial stability in that case makes this market extremely interesting. And I mean, it's also a lot of passion around it. I mean, how to balance the market, how to consider all these environmental constraints. And I mean, right now we are more talking on a global level, but you can imagine that on a local level, there are a lot of constraints that are that needs to be considered, which makes it very, very difficult and extremely challenging exercise.
Yeah. I have one more question at the end. As a follow-up, do you use any tools, machine learning ops, for complete handling of the machine learning life cycle? Sorry. Christian?
Until today, not really much, because most of my work was kind of research. So you do the research, you publish a paper, and that was it. Rarely this model was actually put into practice to live. And but right now, as I said, we're doing some project, and we're trying to use ML flow. ML flow is something new. Well, new. It is something that we believe can be used for the life cycle of the machine learning model, to deploy it, to update it from time to time, to monitor the performance. So that is one of the tools that I am aware of, and we are kind of using it at the moment.
Thank you, guys. We are out of time, actually, 6 minutes out of time. There is some more comments thank you guys for the comments. We will continue with this kind of episode. This podcast will continue with the help of data science and Scalefocus especially. Thanks once again, and have a nice evening. Good night, guys. We will see you in the next episode. Bye-bye.
Thank you for the invitation.
Bye.
Bye-bye.
Thank you. Bye.